Hello everyone. Today we are going to see the design of piston. That is, in the earlier video we have seen about design of cylinder and design of head. Design of cylinder head. So in this video we are going to see the design of piston. So what is piston? It is a reciprocating part of an IC engine. What are the functions of the piston? Transmits the force of gas pressure inside the cylinder to the crankshaft to the connecting rod. So it compresses the gas in compression stroke and dissipates the large amount of heat from the combustion chamber to the cylinder wall. Here we can see the construction of the piston. In this diagram you can see here is the piston head. The cup type shape is called as a piston head or crown. This is, you can consider the top land. Here is the ring section. Here is the skirt. Then piston key is there. This one. Then piston boss, and here is the rim, and here is the piston barrel, and these are the grooves which are provided for the compression tubes. So first we will see a part, that is piston head or crown. Here it is piston head or crown. It withstands the gas pressure inside the cylinder, and its shape should be flat, concave or convex. The piston rings. The function of the piston ring is to seal or prevent the leakage of a gas. Then piston skirt, it is the lowest part of the piston below piston rings. Here you can see the piston skirt. Then piston pin, here you can see the piston pin. It connects the piston to the connecting rod. Then we will go for the design requirements. So the sufficient strain, it should be required to withstand the force of a combustion. It should have the sufficient rigidity to withstand the thermal and mechanical distortions, the adequate capacity to dissipate heat from crown to the cylinder wall, and efficient seal to prevent the leakage of flue gases from the combustion chamber. So these are the design requirements of the piston. The material for the piston. The materials are the cast iron, cast steel, forged steel, cast aluminum alloy, and forged aluminum alloys will be used for the manufacturing of the piston. The thermal conductivity of aluminum is approximately 3 times that of the cast iron. The density of the aluminum alloy is 1/3 that of the cast iron. Cast iron pistons have higher strength compared with the aluminum alloy pistons. So wear strength of a cast iron is more than the aluminum alloy pistons. So by considering all these factors, we can select the appropriate material for the piston. The design of a piston head. So the criteria for calculating the thickness of piston head, strain and heat dissipation. So piston head in a flat circular plate of uniform thickness. Here you can see the cross-sectional view of the piston head, which is having thickness TH. TH is nothing but thickness of the head. So according to the Grashoff's formula, we can calculate the thickness of head. The formula is D into square root of 3/16 into P max by sigma B, where TH is thickness of the piston head, D is the cylinder bore diameter, P max is the maximum gas pressure, and sigma B is the permissible bending stress. P is for the bending, sigma is for the stress. So sigma B, if you consider the bending stress, permissible bending stress is equal to the permissible tensile stress, is nothing but ultimate tensile stress to the factor of safety, where the permissible bending stress, and for the cast iron aluminum alloys we can take it in the range of 35 to 40. Here is in the range of 50 to 90. So P max is the 8 megapascal. The average value is 4 to 5 megapascal. So these are the assumptions we need to consider while solving the problems. Then the empirical formula for the thickness, that TH is equal to 0.032D plus 1.5. On the basis of heat dissipation, thickness of piston head, that is TH, is equal to H upon 12.56 K TC plus T into 10 raised to 3. So here is another formula if it is on the basis of heat dissipation. So H is nothing but it is the amount of heat conducted through piston head in a watt. Then K is a it is a thermal conductivity factor in Newton per meter per degree Celsius, and Tc is the temperature at center of the piston head in degree Celsius, and T is the temperature at the edge of the piston field in degrees Celsius. So the K value, that is thermal conductivity factor for the cast iron and aluminum alloy, is fixed, that is 46.6 watt per meter per degree Celsius, and here is 175 watt per meter per degree Celsius. Now the permissible temperature difference, that is Tc minus T, for the grey cast iron and for the aluminum alloy, it is fixed. For the grey cast iron it is 220 degrees Celsius, and for the aluminum alloy it is 75 degrees Celsius. So these are the assumptions that you need to remember when solving the problem. So amount of heat conducted through the piston head, that is H, we can calculate by using this formula, where H is equal to C into HCV into M into Bp into 10 raised to 3, where HCV is, it is a high calorific value of a fuel in kilojoule per kg, where M is mass of a fuel per brake power per second, that is kg per kilowatt per second. The brake power is the Bp is the brake power of the engine in kilowatt, where C is the heat absorbed by the piston divided by heat developed in the cylinder. It is of 5%. It should be taken as a 5%. It is of 0.0. So M is equal to 0.242.3 divided by 3600 kilojoule per kilowatt per kilovolt per second. So after that, the piston ribs. The piston ribs are used to strengthen the piston head against the gas pressure, and it transmits the large portion of the combustion heat from the piston head to the piston rib. So here, thickness of the head is less than or equal to 6 mm if the ribs are not used, and if the ribs are provided, then in that case you have to take the thickness greater than 6 mm. So number of ribs are in between 4 to 6. So thickness of rib, that is TR, is equal to TH by 3 to TH by 2, where TR is nothing but thickness of ribs and TH is nothing but the thickness of piston head. So the next video you can see the piston rings, the new component piston